things about the project that our sponsor Justice wants to talk about. So instead of talking about like the specific application or the hardware we're using, this is more of like an overview of the topology and the architecture that we're going to use to establish the communication. That being said, so the goal of this project is to have a large number of sensors all connected to the internet, but each individual sensor doesn't have a lot of data that it needs to communicate back to the sponsor that we have. And so what we're doing is we have all these sensors, we call them nodes, and we want to have them all connect to a central access hub. And that access hub will be the only thing that's actually connected to the internet, and all the sensors will just relay their data to that access hub, and that will get it up to the cloud. So you can kind of see the general architecture right here. The nodes are connected to the access hub, back to the cloud, like I just described. And the general way that the nodes will, like the data flow will go, is that the nodes will collect the data, it'll sample, and then wirelessly communicate the data back to the access hub, which will then communicate to the internet. And we're using all wireless technology because that's another big constraint of this project. They want all the sensors to be wireless. And so we're actually using two different wireless protocols to achieve that. So the sensors, they need to have a long range to be able to communicate with the access hub. So we're using a sub-gigahertz protocol to improve the range, and it doesn't need to have a very big data throughput, but we want to keep them low power. So sub-gigahertz just seemed like a good choice considering all of those constraints versus like a 2.4 gigahertz solution. And then for the access hub, we decided to go with cellular technology, again, because we want it to be wireless. We want the solution to be able to be implemented anywhere, kind of just like a plug-and-play type scenario where you wouldn't have to get established on any pre-existing LAN network or any other kind of network. We're just establishing our own isolated network that can go anywhere. And then as far as like some actual hard numbers for the metrics that we're trying to achieve, we want to have 100 nodes connected to one access hub. And so obviously that's going to take a lot of coordination. And the type of data that we're sampling should only need to be about like once every minute. And so the access hub will have to do a lot of coordination between all the nodes because we're going to have that many all on the network. And then the cellular technology, that should be plenty of bandwidth for us to get all of that data back up to the cloud for them to do whatever post-processing and whatever else they want to. And then for the range, we're shooting for a minimum of 100 meters for the distance from the nodes to the access hub. There could be some other factors that affect that, but that was kind of seems like a good general number to shoot for. And so yeah, considering all those things, we're going to have some different optimizations. We want to keep the nodes really low power if we can, which is, again, is kind of helpful because it's not a very big data throughput, so kind of using things like low power modes and being smart about the way that we schedule the data backhaul. And one other requirement of our project is that it needs to support over-the-air updates so that once this solution is deployed somewhere, we can update the firmware and debug the code that's running on the nodes without having to go and collect them all back up and reprogram them. I think that's everything. Anybody has any questions? Yeah.
If you can talk about are the nodes like an IPv6 node? Do they have all the intelligence, or are they kind of a master-slave relationship?
Yeah, it's a much lower level.
Okay.
It's
It's just simply sensing data through the ADC and then using a part of several gigahertz protocol, sending data over back to the access hub, and the access hub actually just sits there, aggregates the data, and then eventually backhauls it onto the modem, and the modem sends it out.
So the modems are actually IPv6 elements off the network that the nodes are
Well,
juggling.
the modem is it's using it's actual LTE modem, so it's a category 1 modem.
Okay,
Yeah, so you have to use that commands for that.
got it.
Is the purpose to be fully autonomous battery operated, or is this going to be hooked to the power or something like that?
So initially, the goal is to have all the nodes be battery operated, or battery powered, and that's why like the low power was kind of the big thing.
What's your operational time goals?
Right. So once we started getting more into the thick of that with our sponsor, they kind of wanted to put that on a back burner and focus more on like for the prototype getting just getting like the network established because they don't really know how far we're going to get throughout this semester and the next. So they kind of wanted to focus on other things. But when we initially were talking about having it be battery powered, it was around a year, I think. So we might circle back around to that
having one modem that can aggregate all this data, and then push it out is,
Commonality, that's what I'm trying to do. It's already been done,
okay.
right?
Do you get to choose what protocol it will be? If it's going to be 802.11ah, which is sub-1 gigahertz, or any other sub-1 gigahertz?
It's 802.16.4, and then 802.16.4, whatever topology that you want to actually build on top of that. So if it's a star network or if it's a peer-to-peer mesh network.
What is the selection of the communication protocol dictated by the sponsor, or is that part of the project?
So that's based on certain optimization, kind of what we're going for, if it's going to be range, how many, the speed of the actual transmission